Hello and welcome back to another LeetCode video. Today we're going to be doing problem number 75, sort colors. And I'm going to show you the most efficient sorting algorithm there is, I think. But it's only applicable in certain situations. So let's go over the problem. Given an array nums with an object colored red, white, or blue, sort them in place so that the objects of the same color are adjacent, with the colors in red, white, and blue. We will use the integers 0, 1, 2 to represent red, white, and blue. You must solve the problem without using the library sort function. And so when you're given this, you want to return this. Okay? And then for the last one, it's also pretty straightforward. So let's think about how we could do this. So we're given a red, a white, and a blue, and this is important. Like we know our elements, and this is going to be the key for this kind of sort. If we know what kind of elements we have, especially if you don't have like too many different types, it's even more efficient. So how would we do this, right? Like if we just do a sort, like a quick sort or a merge sort or any of those, that's going to be n log n. But because here we actually know the elements we have, how would we, like, what can we do to make it more efficient? And then we know also that we have to have the red elements, then the white elements, then the blue elements, right? So it's going to look like something like red, 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 however many reds we have, some whites, and then some blues. Well, so how do we do this? That's like really efficient, and it's actually pretty straightforward. So if you know what elements you have, especially if you don't have too many, you can actually just make variables for these. So like you can just make a red, a white, and blue. We can go through the array, and then we can actually count up how many of each we have. So like for this example, let's say our red is 0, and then our white is 1, and then our blue is 2, right? So what we would do is we would go through the array, right? And so we would like add these things, right? So we'd have a 2, so we'd have blue equals, let's just make these like whatever, let's make it 1. Now we go to a 0, right? So we went to a 2, we would go to 0. Okay, now this is 1. Okay, we go over here, update that to 2, and so on, right? I mean, that's pretty straightforward. Go over here, update this to 2. Go over here, update this to 2. So now that we have 2 reds, 2 whites, and 2 blues, like all we have to do is just get a count for each, and then we know that like our array is gonna have 6 elements. So we can literally just say like, okay, let's start with our reds. Let's print reds until we have no more reds. So it's going to be like red, red. Oh, well, actually, in this case, they want it to be zeros, ones, and twos. So we can just print like 0, 0. And then once we have these counts, we don't really care what was in our original array. We can just start writing over it. So we write 2 reds, then we write 2 ones, and then we write 2 blues. And so the reason this algorithm is really efficient is because you know exactly what you know exactly what elements are in your list ahead of time, and you're not always going to know that. So if you're not always going to know that, it's not going to be nearly as efficient, because like you could technically like go through your elements and like figure out what's in there, but if there's a bunch of elements with like a bunch of gaps, it's not going to be nearly as efficient. But if you know exactly what types of elements are in there and you know exactly their order, right? So we know we have reds, then we have whites, and we have blues. And so we can just get a count for each. And this is called a bucket sort, because we have these buckets, right? So we have a bucket for reds, we have a bucket for whites, and we have a bucket for blues. And then we know like the exact order. So anytime you know like the exact elements you have that you're trying to sort, and they're not too many, and you can group them into these buckets, then this is going to be the most efficient algorithm. So this will only be I mean, technically it's a 2-pass, right? So we're going through one time to get these buckets, and then we have to go one more time to like actually write them down. But that's still going to be O of 2n, which is big O of n essentially, where a normal sorting algorithm is n log n, right? So we still have a more efficient algorithm here than here. Because let's say like n is like 50,000 or something, and we only have a few buckets, then 2n is going to be, you know, let's say like each time you go to something is like a second. Technically, it's not going to be, but let's just say it is. So then it's going to be, you know, 100,000 seconds, where n log n would be something like 50,000 times like 20 or 30. So we kind of like made our algorithm like 10 or 20 times more efficient by doing it this way, right? Because this is 50,000 times 2, and this 50,000 times like 20 or 30. So hopefully that's something new to you, and let's code it up. So we are going to have a reds, whites, blues equals 0, 0, 0 to start. Then for num and nums, we are going to just have some if statements here. It's pretty straightforward. So if num equals 0, so remember reds are 0, whites are 1, and blues are 2. So we're just going to go through, and we are going to increment our stuff correctly. Hopefully this is spaced right. So yeah, definitely once you like learn this bucket sort trick, this question becomes pretty straightforward. But if you didn't, then it would be tougher. And then if num equals 1, right? You could definitely like make this. You could definitely like store these things in a more efficient way. Like let's say you didn't only have 3 numbers, you had a lot. You might want to have like a dictionary or something, you know, like, and then you could have keys, and then like a counter type of thing would be totally fine. But for now, since we only have 3, we can just have these numbers. So okay. So now we have to do one more pass through the array. And so it's going to be pretty straightforward. And what we need to do is we need to maintain like the index we're at. So we'll just say index equals 0. And then we can say, we can just, yeah. Actually, let me think how I would do this. So you could have 3 while loops where you just have like, you just keep writing until you, until you're like out of your stuff. I guess technically that's fine, whatever. We're not going to focus on writing super optimal code here since it's only like 6 lines of code anyway, so let's just do that. It doesn't really matter. Okay, so, and runtime wise, it's going to be like as efficient as it gets anyway, because this will technically be another 1 pass. So while reds is greater than 0, we can just write in our stuff. So we just do this 3 times, right? There we go. So yeah, if you wanted to make it more efficient, you could definitely have a dictionary type thing and then some other like list comprehension thing, but this is whatever. Okay, and then nums index is 1. This is whites, blues. Yeah, I think that's it. So we don't need to return, we're just modifying in place. And so yeah, basically we're starting at index 0, and then we're just printing a red until we have no more reds. So this should, if our calculation was right, it should like update our stuff correctly. Now we do have to also update our index, but that's pretty much it. Okay, hopefully it. Alright. But yeah, I don't really want to focus on like writing efficient code for like a 10 or 20 line thing anyway. I just wanted to show the bucket sort, which is the more important concept here, where remember this is going to be a, so when we do the time here, this is going to be a big O of n solution as opposed to the normal sort that's n log n. So that's why this is the most efficient sorting algorithm, because sorts are either n log n or worse typically. So space. We didn't actually make anything else. We just use these 3 variables. But yeah, what I would say is if you had like, let's say you had numbers 1 through 10 or something, and you'd have a bunch of counts, and your numbers 1 through 10 with buckets, then you probably don't want to have like this reds, whites, blues, like, you know, you don't want to have like ones and all this stuff. So the way to make it more efficient would just have some kind of like, you know, dictionary where it would be something like D of like number that you have 1 through 10, and then you have a count of the number, right? So something like that. And then you can just go through your numbers, and then you could say like, while until my count is greater than, or until my count is 0, let's just keep writing at the index I'm at. So that would be like cleaner code for that. So I could have done that as well. You could, instead of reds, whites, and blues, I could have just made these like key 0, 1, 2, and then I can just go through the dictionary at my current key, and then when it's 0, then I update the key by 1, I update the key by 1, I update the key by 1, and so on, until my key is no longer in the dictionary. So that would be how you would scale this up for a, more numbers instead of 3. Okay, so hopefully you liked this problem, and if you did, please like the video and subscribe to the channel. And thanks for watching, and I'll see you in the next one. Bye.